Bitcoin Core. So for our presentation, first we'll talk about our proposed enhancement, and then we'll talk about approach 1 and another alternative approach. And then we'll talk about its high level and low level interactions. After that, we'll perform SAM analysis on the different approaches, and then we'll present 2 use cases for the new enhancement, and then we'll show potential risks, concurrency, lessons learned, limitations of our findings, and the conclusion.
Our proposed enhancement is to increase the number of transactions that can be handled by the system and in the blockchain. With this improvement will improve the scalability and throughput of the system, and we've proposed 2 different approaches for this enhancement.
So for the first approach, we will add a additional blockchain manager component that specifically deals with processing more transactions. And with this component, we have new dependencies such as from the TXS component to blockchain manager, mempool to blockchain manager, and blocks to blockchain manager. So this is our new conceptual architecture added with our enhancements. So as you can see, we have blockchain manager in the middle. Okay. So for the high level interaction of this enhancement, we have TXS component gives the transaction information to the blockchain manager, and then the mempool gives out the transaction queued information. And then finally, the blockchain manager hands over the processed transactions to the blocks component. And for the low-level interaction, as you can see, we have different subsystems from TXS index and blocks blockchain subsystem and the mempool ARCs subsystem. And then these subsystems are all connected to the blockchain manager, which has the blockchain info, the queue, and the processing subsystem.
For approach 2, we added subsystems in the blocks component. The processor processes information from the other components, and the adjuster can adjust the block size of the transactions. Some directories and files that this will impact are a processor and adjuster directory and mempool blockchain and index files in the system. This is our new conceptual architecture for this different approach, where we have the new dependencies of the new subsystems of the blocks in the architecture.
So for our SAM analysis, we identified the major stakeholders for the system being the developer and the user. And the most important NFRs for the developer is scalability, maintainability, testability, and performance of the system. And for the user is usability, performance, and capacity. And as we compare approach 1 and approach 2, for testability, the approach 1 is certainly better because it has one standalone component in the overall architecture, whereas approach 2 has 2 additional subsystems, and it's definitely a lot harder to test and trace where all the operations come from. As for maintainability, approach 2 is easier because it only has 2 additional subsystems, where it has approach 1 has one new entire component. And as for robustness, approach 1 is certainly better because it is more flexible in dealing with transactions. So approach 1 is the approach we choose.
For use case 1, making a transaction, we have the application request a transaction from the user, which establishes a connection with the connection manager, which will connect with will request keys for encryption with the wallet and return keys. When a key is returned, it will create a request to send a transaction to the TXS, which will queue up transaction with mempool, validate the transaction in validation engine, which will confirm it, send the transaction queue information to the blockchain manager, update the blockchain, update number of Bitcoins, and then confirm the update and return the transaction hash back to the connection manager.
So for use case number 2, we are making a transaction with high priority. So the user, like the first use case, it requests a transaction, which will establish connection to the connection manager, which will request keys for encryption in the wallet. And then after that, it will create a request to send a transaction to TXS. And this time it skips over mempool to validate transaction to the validation engine. And then it sends transaction information to the blockchain manager. And after that, it will call the blocks to adjust block size and finally update the blockchain. And the blocks will call the storage engine to update number of Bitcoins.
So the plans for testing are to have user-focused tests and developer-focused tests. And for the user-focused tests, we want to test on usability, performance, and capacity of the changes. And for the developer-focused test, we want to test the scalability, performance, maintainability, and testability. Some potential test cases we have are to have tests that ensure that no new faults were introduced. We want to check if the new architecture can handle a large volume of transactions better than the old. And we want to test if maintainability, maintenance stuff at the time is less than before, as well as test the capacity, that the capacity improved when handling number of transactions that require heavy encryption compared to the previous system.
So some of the potential risks are that some malicious actors can exploit the vulnerabilities that are introduced with this component and may result in fraudulent transactions. Also, the new enhancement will have conflicts with other platforms and result in less compatibility. And for the final point, the blockchain manager handles too many transactions and that may result in too much centralization.
The concurrency of our Bitcoin system uses multi-threading. The components like RPC act as a thread, and the blockchain manager helps enhance the concurrency of the system even more.
So for lessons learned, we learned the importance of testing and SAM analysis. We gained insight on how modifications to the architecture can affect high-level and low-level interactions of components. And also, we learned the importance of communication for our group because we couldn't meet regularly, so we divided our tasks and communicated through text.
Some limitations are that we did not go in depth about the source code. We were limited understanding about blockchain and concurrency, and we do not possess the technical details needed to implement the enhancement fully.
So for a conclusion, we propose a enhancement to resolve the scalability problem of the Bitcoin system. And we performed SAM analysis for different approaches. And we also came up with plans for testing and identified some risks for the enhancement.
Thank you.
Thank you.